Hi everyone, we are going to go over section 4.8 today, graphing inequalities. Graphing inequalities is similar to graphing linear inequalities. You're going to graph the boundary line and then shade what makes it true. With quadratic inequalities, graph the parabola and then shade the inside or the outside, whichever one makes the inequality true. To solve a quadratic equation by graphing, follow the same method. Okay, so we're going to do two different things with these quadratic inequalities. The first thing is we're going to solve it by graphing. The second thing is we're going to solve it algebraically. So on the first one, number 1, y is greater than negative x minus 6x minus 7. Sorry, I forgot my squared term. Negative x squared minus 6x minus 7. Okay, so you can either change this into vertex form and get your vertex that way, or you can use the x equals negative b over 2a to get your vertex. And I'm going to just change this to an equal sign just for purposes of solving it. I want to write it in vertex form. So first I want to take the negative 1 out of my first two terms, my quadratic and my linear term. So everything is going to be positive now. And I'm going to keep that minus 7 outside the equal sign, or outside the parentheses, sorry. Now I'm going to take my linear coefficient, which is a 6, divide by 2, and square it. So I'm going to add 9 inside the parentheses. Outside, I'm going to subtract a negative 9, and it's a negative 9 because 9 times that negative outside the parentheses makes it negative. Okay, so now I can factor into a binomial squared, so x plus 3 squared, and my number outside is going to be a plus 2. So my vertex, and I'm going to go ahead and write it as inequality. Nothing, the sign did not flip because I didn't multiply or divide by a negative, so it's all good. Okay, my vertex is going to be at negative 3, positive 2. The negative out front means it's going to open down. So let's graph this. And I can make a table of values over here. Start with my vertex. So negative 3, positive 2, there's my vertex. I can put two other points in there like negative 2 and negative 4 and just substitute in to get my y values. Okay, so I'm getting positive 1 for both of those y values. So that means I have negative 2, positive 1, negative 4, positive 1. And since it's only greater than, my parabola is going to be dotted. Okay, so there's my parabola. And now I need to decide if I want to shade inside or outside. So I can take a point not on the graph, like 0, 0, and plug it in. So I'm going to plug in 0, 0. Okay, if 0 is greater than 0 minus 0 minus 7. Is that true? Is 0 greater than negative 7? Yes, that's true. So I am going to shade outside the parabola. And that is how you solve by graphing. Okay, to solve by graphing, let's look at solve algebraically. I'm going to look at number 5. Let's look at number 5. X squared plus 2x minus 3 is less than 0. Okay, so I want to write the 0 on the other side just because I like 0 is like your y. So I want to put it on the left side, and the bigger arrow or the bigger part is pointing towards the 0. So I'm going to flip the inequality, x squared plus 2x minus 3. So what I want to do here is I want to solve for x just like I normally would, just like if this was an equal to. In fact, I'm going to make it equals so I can factor it and solve for x. Okay, so if you want to use the quadratic formula, that's fine. If you want to complete the square, that's fine. you can use whatever method you want to solve for x. I'm going to factor. 2 factors of negative 3 that add to be a positive 2 is going to be a positive 3 and a negative 1. So I'm going to expand this middle term with a plus 3x minus 1x minus 3. And now I can group and factor. The first 2 terms have a factor of x in common. I have x plus 3 left in parentheses. The last 2 terms have a factor of negative 1 in common. So now I have identical binomials, and I can consolidate the x minus 1 and write x plus 3 one time. Okay, so now I'm ready to set each of those factors equal to 0. So x equals negative 1 and positive 1, and x equals negative 3. Okay, so now what we're going to do is we're going to draw a number line, and we're going to plot those 2 points on a number line. Here's negative 3, and here's 1. So I have this divided up actually into 3 sections. There's one section. There's another section. So what I want to do is I want to pick points from each section, substitute in, and see which one's going to make it a true statement. So if I want something less than negative 3, I could choose like a negative 4. In between negative 3 and 1, I can choose 0. Anything greater than 1, I can choose a 2. And I want to see which one is going to make my inequality true. So let's just start with the 0. When x equals 0, you got 0 is greater than 0 plus 0 minus 3. Is 0 greater than negative 3? Yes, it is. So this is true. Okay, let's just check this negative 4. When x is negative 4, I have 0 is greater than negative 4 squared is 16. I'm plugging it into this equation, into inequality. Plus 2 times negative 4 is negative 8 minus 3. So 0 is greater than, that's going to be, like, I think it's going to be 5. Positive 5. Is that true? No, that's not true. That's false. So that one's not going to work. Okay, and then one more. X is 2. So I'm plugging it back into this inequality. 0 is greater than 4 plus 4 minus 3. That means 0 would be greater than 5 again, which is false. That's not true, so that's not going to work. The only one that works is this section between negative 3 and 1. So your answer would be negative 3 is less than x is less than 1. And you only use the less than, not equal to, because that's what it was originally. Okay, so we'll look at this again tomorrow. Make sure to write down any questions you have. And have a good night. See you later. Bye-bye.